Hello and welcome to my YouTube channel. In this video, we are going to develop a second project using DMA, and in this project, we are going to transfer data between peripheral to peripheral. So let's start the video. In the previous video, I showed you how to use DMA for memory to memory data transfer. And if you can recall, the utility of DMA is to bypass the CPU so that we can directly transfer the data between memory to memory, memory to peripheral, or peripheral to memory without CPU's intervention. And during that time, CPU can do some more important tasks and hence increasing the performance of the overall system. In this case, or in this example, we are going to implement this project in which we are going to transfer data from peripheral to another peripheral. And for this demonstration, I am going to use ADC. For that, I will be using a potentiometer to provide the data to the ADC. The ADC will read the data and transmit that data to USART, and all this operation will take place without the intervention of CPU, or we can say the operations will be conducted via DMA. And now let us try to generate the project. For that, let me start the cube IDE. In this, we are going to start a new project. Go to File, New, STM32 project. It will take few seconds to initialize the target settings. And like always, we will select the microcontroller board. For that, I will use Nucleo F44 6RE microcontroller board and click Next. Give a name to the project. So here we are going for peripheral to peripheral data transfer using DMA. So this is my project's name. If you want, you can make it small, like P2P data transfer or so on. So let me just make it capital. Okay, and click Finish. So initialize all peripherals with their default mode. No, we don't want to initialize the peripherals in their default mode. This will take us to the STM Cube MX perspective, where we will have to initialize the ADC and USART for our project. Okay, so here we are in the CubeMX perspective. First of all, let me clear out the pins. For that, I will go to Pinout, clear pinouts, and it will generate a warning. The pinout configuration will be cleared. Would you like to continue anyway? Yes, we want to clear the pinout. Now, our task is to configure the pins for ADC and USART. For that, I can click on PA1 and we can see ADC1 in 1. We will use this pin for reading the analog data from the potentiometer. Right click on that, give it a name. Let us call it potentiometer. And then we have to initialize the USART. Remember, USART number 2 is directly provided by the microcontroller board. For that, we will go to Connectivity and select USART 2. And here we will have to configure the USART. Okay, for that we can take the USART mode to asynchronous, and then let me check if we have to change anything here. So here you can see baud rate is 11,5200. Word length is 8-bit. Parity none. We are not going to change anything. If you want, you can change the baud rate to your choice, like 9600 or so on. After this, we will go for the DMA settings of the USART. Let us go to DMA settings, click add, and we will use USART to TX. Okay, and here we can see what are the parameters available. So mode is normal and it will transfer data from memory. So instead of using normal, let us take circular mode, so that the data will keep on transmitted, or it will be keep on publishing on the USART console. So for that you can use circular mode. So in circular mode, the data will be always fetched continuously by the DMA. Okay, so here we can see USART to TX, DMA1 stream 6, memory to peripheral, and priority is low because we are not using any other DMA module or any other interrupts. Therefore, we can keep the priority low. So with this, we can directly generate the code. Let me rearrange it. We can generate the code by using device configuration tool code generation, or you can click on save all. I will prefer device configuration code generation. Now we will enter into the C perspective. Here we are in the C perspective, where we will have to write the code. So first of all, instead of having such a long window, let me just compress it or collapse all the windows. So go to folding, collapse all. This makes the program a bit tidy, and now we can easily go from one section to another section very easily without scrolling too much. Now let us start writing the code for the DMA. So first of all, I will go to the variables declaration. Here you can see user code begin private variable. Remember, always keep your code within the user section. Otherwise, whenever you make or any modification in the CubeMX perspective, all the codes will be deleted. So always keep your code within this user code sections, like here user code section, here, or user code section like here. Okay, so let us declare the private variables. So we will be using two private variables, uint32 underscore t adc value, and then character array msg at. Okay, first variable will be used for collecting the values from the ADC, and second variable will be used to pass the variable data to the USART. Now let us go down and start writing the code for the main loop. So I open the main loop, go down, and we will write the code within this user code area. Okay. Now first of all, we will have to start the ADC conversion. Okay, for that we can use hall underscore ADC underscore start. Okay, and pass the handle. Done. Then we will have to poll for conversion. If you can recall, we have done the same task in the previous video when we were reading the data from the ADC. Okay, we are going to use almost same code. Okay, conversion complete, and here we can write all underscore ADC underscore poll for conversion, pass the handle and timeout. So let us take all max timeout. Okay, delay. So if you have any doubt regarding how to get these functions, then it is very easy. You go to drivers, go to STM all drivers, go to source where you will get all the C files. Okay, and here because you are going to write code for the ADC, you can open all ADC.c, under which you can open the outline window, and in the right you can see all the functions which are available related to ADC. Okay, you can go through them one by one. For example, all ADC start and read about those functions. It will take maybe 1 or 2 minutes to read about these functions and then utilize them according to your use. Okay, so here we can see enables ADC and starts the conversion of regular channels and so on. And then for poll for conversion, you can go for here, and then you can read poll for regular conversion complete, ADC conversion flags, end of sequence and end of conversion are cleared by this function. Note, this function cannot be used in particular setup. ADC conversion, ADC configured in DMA mode. So right now ADC in our case is not configured in DMA mode, rather USART is configured in DMA mode. So let me continue with the coding. So now we will have to read the value, ADC value equal to all underscore ADC underscore get the value. We will have to pass the handle. Okay, done. So we have read the value and stored the ADC value into the variable ADC value. Then we can stop the ADC, all ADC underscore stop. Okay, pass the handle, done. So this section will just read the values and store the value in ADC value variable. So this will just get the ADC value. Okay, and here this will stop ADC. Now we will have to write the code for UART or USART. So we will use sprintf message ADC value is %LU. Why we are using LU? Because we are using long unsigned 32-bit integer. Okay, otherwise if you are just using integer, then you can use %D. Okay, and then ADC value. This function will store the value of this whole message in this variable message. Okay, and we have defined message variable. It can store up to 80 characters. So now coming down here, all underscore UART. Now remember, we are going to use the UART in DMA mode. Okay, so we will use this UART transmit underscore DMA, pass the handle. Now the data that you want to pass, so MSG and comma the length of the message. So we can use strl string length, okay, msg. Now the question comes, when we try to, okay, let me just provide a small delay, hall underscore delay, okay, and let me keep the delay of 500 millisecond. Done. So this is all the coding part required for transferring the data from ADC to USART. And here, if I compile this project or build this project, click on the hammer button, and let me check if there are some errors, 3 errors and 5 warnings. So first of all, because we are using functions related to printing, printf, okay, so we have to include our own files. For example, hash include, we'll have to use standard io.h first for this sprint function. Second, in this we are using strl length. So for that we will have to include hash include string .h. Okay. Now there are, let me just rebuild the project, and you can see there are still 2 errors. Let me go down and check where these errors are. Again in the same area. So this should be n. Okay, done. And here in this part we have to provide the address of the message or the variable where you are keeping the data. So uint, I'm going to typecast it to 8-bit because we are going to print characters. Okay, typecast the pointer to message. Okay, and let me rebuild the project, and we can see 0 errors, 0 warnings. Now let me connect the board, upload the code, and see if the DMA is working properly or according to our requirement. So let's just go to the debug configuration, open the debug configuration, wait a second, it has started the debugger. I will stop it and reconfigure it. Stop the debugger, go for debug configuration, go to debug. Here check whether we are using GDB server, st-link, scan the board, get the ID of the board, come down, enable the serial wire viewer if needed. We can even plot the functions, okay, and apply and debug. Now let me just open the camera so that you can see the board and the potentiometer. Now the program is halted here, and we have to check whether the message is coming on the console or not. For that I can go to console and open the command shell. If you don't know how to configure the command shell for serial select remote connection for serial port, then please visit my previous videos. So we have developed or created one remote connection named com8 11522, sorry, level 5200. So let me open the function, and now here the COM port is waiting for the message to be published by the UART. So let me run the code, or because we are also having a variable, let me just add the variable ADC value, and here we can see the ADC values in the live expression. So whenever I will be making any change in the potentiometer, we will be able to see all the changes in the live expression. So let me resume the code, and we can see the data coming to the ADC variable, and similarly we can see the data is printed in the serial console. Let me just make some changes in the potentiometer, and you can see the ADC value has changed, and that is getting printed in the USART or serial console. And if I pause the program, you can see, just a second, let me pause the program. You can see we are somewhere in the halt delay, but CPU is not involved in this transaction. So with this, I would like to end the presentation. Okay. Now, if you have not subscribed the channel, then I would request you to please subscribe the channel and click the bell icon so that you will get the notifications as soon as I upload a new video. If you have not pressed the like button, then I would again request you to please press the like button. And if you have any suggestions or comments regarding this video or any other video in my playlist, then please share your comments and suggestions in the comment section. Thank you and have a nice day.